All right, picture this for a second. We're stepping right into the deep, humid shadows of the Amazon rainforest. You're completely surrounded by a million shades of green filtering the intense tropical sun from above. And somewhere in that dense, sprawling canopy hides a biological marvel that challenges pretty much everything we intuitively know about anatomy and survival. Today, in this explainer, we're going to look at a creature that seems to totally defy logic.
Just look at this little guy. You are literally looking straight through the living skin of a vertebrate. This is the glass frog. I mean, check out that internal machinery. Right up there in the upper center, that dark red shape is a tiny, actually beating heart. Right below it, you can trace the whole winding path of the digestive tract. And clustered over on the side, those pale, perfectly round green orbs, those are eggs, just waiting to be laid. It's exactly like looking at a living, breathing X-ray. Which brings us to a massive, honestly kind of unsettling biological puzzle. Why on earth would you reveal your internal organs to the whole world? Out in a hostile jungle packed with birds, snakes, and insects, all looking for their next meal, having your most vital, delicate systems completely exposed seems, well, completely counterintuitive, right? Evolution usually builds armor, it builds thick scales, fur, or hard shells. It rarely builds glass windows. So why would nature engineer such extreme vulnerability?
To understand this masterpiece of evolutionary engineering, we have to unpack how this actually works. Let's dive right into Section 1, the transparent mystery. Biologists call this condition ventral transparency. Now, ventral is just a fancy scientific word for the belly or the underside of an animal. And transparency, well, that speaks for itself. It's a phenomenon where the organism's underside completely lacks pigmentation. The pigment cells, the things that give human skin its tone or a tiger its stripes, are just entirely absent on this frog's belly. The skin is definitely still there, keeping everything safely inside, but it's rendered completely crystal clear. Now, look closely at this view of the frog pressed up against the surface. You can actually trace the delicate vascular system, all those thin little veins branching out. You can see the fine skeletal structure of its legs and that pristine, translucent webbing between its golden-tipped toes. It looks so incredibly fragile, almost like it's made of spun glass, right? It really emphasizes this delicate vulnerability. You'd think this makes the frog an easy target, but as we'll soon see, this isn't a weakness at all. It's a highly sophisticated, deeply calculated defense mechanism.
So it's time to shift our perspective to the vibrant, protective top of the frog. Section 2, Masters of Green Camouflage.
It's honestly a huge visual shock, isn't it? On one side, we have that clear, organ-revealing belly we've been marveling at. But on the other side, we're seeing the exact same type of frog viewed from above, its dorsal side. It is solid, bright, vibrant green. This incredible biological duality is just mind-blowing. It's literally a creature of two entirely different halves, an open window on the bottom and a painted, solid wall on the top.
And let me tell you, that painted wall is exquisitely detailed. Notice the speckles and the fine texture on this green back. This is the ultimate leafy disguise. Those tiny yellow and dark green dots perfectly mimic the natural imperfections, the little veins, the pores, and the texture of a real rainforest leaf. For a hungry bird or a snake looking down from the canopy above, this frog doesn't look like a tasty snack. It just registers as another leaf in an endless ocean of green foliage. So the crucial takeaway here is how these two vastly different sides work together to create one unified defense. It's this brilliant paradox of invisibility. From the top view, the strategy is pure camouflage, blending in by matching the exact color and physical texture of the green leaves. But from the bottom view, the strategy is shadow reduction. Instead of reflecting light, the belly just lets light pass right on through it. To really grasp why this dual strategy is so necessary, we have to look at the context of where this animal actually lives. Moving into Section 3, Surviving the Amazon Rainforest. And the canopy? It is a literal 3D battleground. Here is exactly how the glass frog survives this high-stakes 3D game of hide-and-seek. Imagine a predator, maybe a snake, looking up from below at a normal, solid green frog sitting on a leaf backlit by the sun. That normal frog casts a dark, solid shadow. That distinct silhouette is a dead giveaway. But the glass frog utilizes something called edge diffusion. Its transparent belly lets sunlight filter right through its edges, softening its silhouette and making those hard borders just melt into the glow of the leaf.
Throw in some predator confusion, because the predator's eye can't quite figure out where the leaf ends and the frog begins, and top it off with that perfect leaf mimicry we talked about. Combined, these traits completely eliminate harsh shadows. The frog doesn't just blend in, it manipulates light to completely disappear.
Nature has literally spent millions of years engineering this tiny creature to be an absolute ghost of the canopy. It's a masterclass in light manipulation and perfect mimicry. So, as we wrap up this explainer, I want to leave you with this. If evolution can make a frog virtually invisible right before our very eyes, what else is hiding out there in the deep Amazon rainforest, just waiting to be discovered? Keep exploring, always question what you see, and maybe more importantly, what you don't.